Lecture 1, Introduction to Microprocessor. Latest new generation Intel Core desktop processor, it is i7 processor. First, just compare the size of this 8085 and i7 processor. This i7 processor size is very small compared to 8085 microprocessors, as well as the size is also very thin. Next, come to the next terminologies, very important terminologies, the features of the processors, the clock speed of 8085. It is a 5 megahertz is a clock frequency. Here it is a clock frequency 5.3 gigahertz. Earlier I told the 8085 microprocessor developed with 3 micrometer technology. But in case of i7 processor, it is a 10 nanometer technology. These numbers used to mean the minimum distance between adjacent transistor in a chip. The transistor used to fabricate this 8085, the totally they used 6500. In this case, 1.75 billion transistors. Just you see the comparison within the 4.5 decades. What is the tremendous advancement in this VLSI technology? They used NMOS technology. Here they used CMOS technology. The data width is 8-bit. It is 8-bit microprocessor. Here i7 processor, it is a 64-bit microprocessor. The data width is very important to define the speed of the microprocessor. It is going to be processed 8-bit at a time. It is going to be processed 64-bit at a time. Just you can look at this graph. The x-axis is year, y-axis is the micrometer in terms of micrometer. So initially in 1980s they used micron technology. Later on submicron, deep submicron. Deep submicron they used it comes around 100 nanometer, and go for ultra deep submicron they used 50 nanometer and 30 nanometer technology. In nano scale these days they are using and manufacturing this i7 processor with the help of 10 nanometer technology. You see this is a 10 nanometer technology. Still there is this going on to fabricate the processor with the help of 7 nanometer technology. We hope in the year 2022 the processor will become with the size of 7 nanometer. The application of microprocessor, desktop, laptop, tablets and servers. In servers they are using Intel Xeon processor. The processor performance is 4 to 5 times faster than the desktop and laptop. The next microcontroller. Why named microcontroller? Same micro means is for better understanding. I picked this basic microcontroller. It's 80C51. Here also this microcontroller is manufactured with the help of CMOS technology. And micro means same 10 power minus 6. The same micron technology used to fabricate this 8051. The controller, this also controller consists of a processor. It processes the information, but microcontroller may be used to some control application. For manufacturing this 80C51, the transistor count they used 50,000. Speed it is at 12 MHz. The year of development Intel in 1980. This microcontroller mainly used in some specific applications. That application have to do some specific task. Okay, not general purpose. It is going to be perform only the specific task. One is washing machine, oven, printer and so on. There are two categories we have to be divided into where that microprocessor and microcontroller can be used. One is the first category. Wherever the high performance is more essential, those application we prefer microprocessor. In the second category, wherever the issues of power, size and cost, and for some compact application we used microcontroller. The name, a difference between microprocessor and microcontroller. It is a general purpose microprocessor system. This is a microcontroller. You just look at this diagram very carefully. Here the CPU. Okay, outside the CPU only we are having a RAM, ROM, IO port, timer, serial communication port. Other than that, you see the desktop and laptop. You having a Ethernet port, USB port, VGA port, and HDMI port, and audio jack, so on. Okay, everything is outside the microprocessor system, the designer have a own choice to improve or increase the RAM size and the ROM size, not indefinitely. Based on the how many bit data size, how many bit address, based on the they have a provision to increase or decrease the RAM or ROM size. And you come to here, everything is outside. This is a processor. The every peripherals it is outside the processor. But in case of microcontroller, it is a processor is inside. It is nothing but computer on a chip. Processor, RAM, ROM, IO port, timer, serial communication. It is everything is packed inside the single IC. But in case of microprocessor, the processor is outside as well as the other peripherals also outside. The each peripheral having the whole IC. But here only one IC, the processor, RAM, ROM, IO, timer, serial port, they can fabricate with single IC. Okay, here the designer have don't have any choice to what is that to increase or decrease the RAM or ROM size. Whatever the size available in the 8051 microcontroller, with the help of that only we can able to perform some application as well as IO port, timer, serial communication. The next, just a definition for CPU, already told the processor, it will execute information stored in the memory. And here the RAM and the ROM is very important part of general purpose processor as well as a microcontroller. Here RAM is a random access memory. It is a temporary storage of the program. It is a primary memory. The current program is temporarily stored in the RAM and is going to be processed. Once the power is switched off, the data is lost, whatever stored in the random access memory. Yes, you come to the ROM, this is a read-only memory. Here only the code, the main code, source code is stored in the read-only memory. It is a non-volatile memory. Even though power is switched off, there is no content loss in the read-only memory. Suppose you for example you take a washing machine, whatever the code while manufacturing they can burn the code on the ROM. Okay, the washing machine has to be perform the same operation for 10 years. Suppose your washing machine condition is good, that washing machine is going to be performing same task. The end user unable to change the code inside the ROM. Okay, thank you.